Time seeing
Yeah,
you.
yeah, yeah. Me too, Santamurthy garu.
We go live, sir.
Yeah, we'll go. No problem.
So, Children Space Club of India welcomes you all children to participate in ATL challenge orientation sessions uh, organized for students for classes 6 to 10 by eminent scientists from ISRO. At the outset, I express my gratitude to Director of School Education, Government of Andhra Pradesh, V. Chenavera Badrudu garu, IAS, and I express my sincere gratitude to the Director of SCRT AP, Government of AP, Dr. Pratap Reddy garu, and all other resource persons. So I welcome today our resource person, eminent person, Dr. B.R. Guru Prasad garu, retired scientist from ISRO, public relation professional scientist, and science communicator. Worked for 25 Indian satellites missions in ISRO. Worked for German Space Agency. Worked in NASA, and he was a panel member in Japan Aerospace Exploration Agency in 2008. So it's my great pleasure, sir, to welcome you to address the students in Andhra and also from other parts of our country. I welcome you, sir, please.
Thank you. Thank you very much. And
Screen
good
share,
evening.
we'll give you screen share, sir. You can.
Yeah. Good evening to all Shantamurthy garu and all others. And first, let me thank from the bottom of my heart for inviting me to do something which I like, which I always like, talking to students at different levels and talking to children especially. So, and at the same time, let me congratulate and let me say hello to all the people from the government of Andhra Pradesh who have been responsible for this Atal challenge related thing. And so, see, the thing is, all these kind of efforts go a long way in inspiring children, in fact, to do something, to take up a challenge, okay, to think, okay, differently. They go a long way in shaping their career in future and provide them confidence to take up challenging tasks in life, not necessarily on pertaining to studies, but in general, as far as leading life is concerned, that aspect also one has to take into account. Ultimately, after getting a good education, one has to choose a good profession, and these kind of things go a long way in addition to curriculum to shape the career of the students. So in that context, it is very, very laudable. Now I am speaking on a subject which is not easy to speak at the level of students in high school or even PU level to a certain extent, or even to small children. But anyway, as usual, with the help of good visuals, I will try my level best to speak on the subject. And now let me, without wasting time, let me directly go to the subject. Okay, so I'm sharing the screen. I hope people are seeing whatever I'm showing. Hello. Hello.
Sir, welcome, sir.
Okay. You are seeing the screen, whatever I'm projecting.
Yes, sir. Yes, sir.
Very much. I'm happy without any
Thank you.
hassles. Okay. So today's topic is 3D technology for reaching space. This is what I saw. For sustaining in space, living in space, how 3D technology can be used. I'll go to 3D technology at a later stage. 3D technology, if I start talking in the beginning itself, it will be confusing. So the thing is, as far as reaching space is concerned, let us concentrate on that first. How do we reach space? Okay, look at that. This you know very well. This is the earth on which we are all living. Okay, the thing is, moon is circling the earth. Let us not worry about the moon, earth. Okay, we have been living on this for quite some time. See, scientists say that humans came into existence. Let us say, whatever we say, some of the properties of humans, we acquired maybe modern man around, let us say, 2 lakh years back, or something like that. It differs. But anyway, we have been living, and humans, they are different, I told you earlier also, compared to any other form of life on Earth, because for thousands of years thousands of years, human beings have been really interested, and they're aspiring to go to space. But aspiration is one thing, and thinking and fantasizing that I'll go in this, I'll go in that, I'll go through some means and all those things, that is different. But you have to have a way to reach space. How do you reach space? It is not easy. It is not like traveling from Bangalore to Guntur kind of thing, because every second you have to struggle against the force of gravity of the earth. So it is not easy even to go to a height of 100 kilometers or 200 kilometers and start circling the earth. So though people have been really interested to go, human beings have been interested to go, it was not possible for a long time. But reaching space became a reality, not for human beings, at least for something which was built by humans. Okay. During the Second World War, big a big rocket was built by name V2. That was built by Germans. Once that was built, based on that experience, okay, as well as based on their own research, the United States and the former Soviet Union, both of them, they started concentrating on building large rockets, huge rockets. See, by 1957, Soviet Union could able to build a huge rocket, and this is the liftoff of that rocket. And this rocket, it was known as R7. Let us not worry about it, name and all those things. This rocket was the one which launched the world's first artificial satellite, the world's first artificial Earth satellite. What does an artificial satellite do? Okay, it travels as a passenger in a rocket like this. Okay, and what it does is it starts circling the Earth. As I told you, moon was also circling the earth for a long time, for 400 crore years. But this tiny sphere, okay, called Sputnik 1, this also started circling the earth, okay, on October 4th, 1957. That is why it was an artificial satellite. Moon is a natural satellite. Now, humans found a way to reach space. How? Through rockets. Even today, we know only one means by which we can reach space. That is rocket. This is the, excuse me, this is the picture of the world's first artificial satellite, Sputnik 1. I told you about the moon. Moon is the only natural satellite of the earth. Okay. Moon is also circling the earth in space. Okay. So this satellite became a tiny competitor to the moon. What was the weight of Sputnik at the time of its launch? It was hardly 84 kilograms. Okay. It was a hollow metal sphere. There was nothing inside except for a battery and a radio transmitter. Okay. And a beeper. That's all. This was the one which reached space. This was the first object to reach space and started circling the earth, and this began the space age. So humans proved, demonstrated successfully that something which they had built, okay, something which they had built could reach space and start circling and could start circling the earth. See, look at that rocket. Even today, we have only one means through which we can reach space: rockets. Okay, so what a beautiful sight it is to see the launch of a rocket. And this is a Russian rocket again. Almost this is the kind of the rocket that launched Sputnik 1. world's first artificial satellite. But anyway, this is a much later rocket, but it looks almost the same. And rockets are the ones which have launched our first satellite, Aryabhatta. They have launched all the satellites, all the human beings who have gone to space, all have reached space through rockets. There is no other means through which we can travel to space. Okay? You cannot reach through an aeroplane, conventional aeroplane. It is not possible. So our first satellite, Aryabhatta, was also launched by a Russian rocket. And look at that. After that, there are tens of thousands of artificial satellites have been launched by rockets, in fact. So tens of thousands of artificial satellites have reached space and they are circling the Earth. Humans have acquired tremendous capability in making something built by them, okay, to reach space and to circle the Earth. Not only circle the Earth, okay, this is one thing. This is the way the satellites are circling the Earth. This satellite is circling the Earth at 36,000 kilometers high. Anyway, I'm not going to talk about this. And these, it is not only the artificial satellites which have gone to space, they have reached space and started circling the Earth. Rockets have been successful in launching spacecraft, robotic spacecraft like this, to space. They have made it possible for robotic spacecraft to reach space and to travel towards the other members of the solar system. Okay, not only to reach space, to travel in space properly towards a destination, you need rocket power. Okay, this is our Mars orbiter spacecraft when it was sitting on top of our PSLV rocket in Sriharikota at the launch pad. This picture was taken. This is the picture of the Mars orbiter spacecraft, and it is sitting on top of this PSLV. This is the last stage of PSLV. Okay, now in addition to making artificial satellite to reach space, as well as the robotic spacecraft to reach space and to reach other destinations in space like Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and even Pluto, okay, rockets have been successful. But in addition to that, rockets have been successful in sending humans to the moon. Okay, 12 people have walked on the surface of the moon. They have reached not only the space, they have reached the surface of the moon and they have come back. See, once upon a time, it was known as manned space flight, and now men and women both are going to space. That is why it is not known as manned space flight. We don't say nowadays, we say crewed space flight, CREWED, crewed space flight. That is, it carries a crew of men and women. Anyway, in the next 5 days, World Space Week is coming, and this time the theme is women in space. So many women have gone to space. One was Kalpana Chawla, who went and circled the Earth. Twice she went and circled the Earth, and unfortunately, she died while coming back from Earth orbit back to Earth. And another Indian, okay, the Sunita Williams. She's also a NASA astronaut and partially of Indian origin. And very recently, Sirisha Bandla, okay, she has a connection with Andhra Pradesh. Okay, she's basically a Telugu person by ethnicity. Though she's an American, just I heard her yesterday talking day before yesterday. She spoke so well like an American because she's brought up there. Okay, so and she went to, she works for one of the companies which sent humans to space. Uh, Only to the edge of space, and along with Richard Branson, they went in a space plane to the edge of space and they came back. So what I mean to say is, not only the robotic spacecraft and satellites, humans have also reached space through rockets. And today we have International Space Station. Okay. In addition to that, we have one Chinese space station. But International Space Station is very big And in that 7 people are working in space. Even at this instant of time, they are circling the earth. All of them have reached space through rockets. Why I'm telling so many times is, forget about anything else as of now. People, that is human beings, have reached space and taken their satellite, spacecraft, everything, okay, through rockets only. So let us see, rockets are the means to reach space for humans. That's why let us learn more about rockets. See, rockets have been successful not only making humans to reach space from the surface of the earth. Rockets have been successful to even reach the rockets have been successful even to make human beings to reach space from the surface of the moon also. This is the picture of Apollo 17 spacecraft. It is sitting on the surface of the moon. Apollo 17 astronauts, 2 of them were inside this spacecraft. They had to go up, okay, in space. They had to reach space, okay. Let us say then they have to, they had to go and circle the moon and join one of their colleagues who was circling the moon in another spacecraft, and all of them had to come back to Earth. Look at that. Rockets can make people to reach space from the surface of the moon also. Look at that.
Attention arm is destined. Okay, I'm going to get the pro. 99, proceeded, 3, 2, 1, ignition.
Look at that.
Right away, Houston.
See the way in which, okay,
Exit.
from the surface of the moon, they are reaching lunar orbit.
Pitch over.
So this is the way. So we have to thank rockets. Okay, they are the ones. Now, let me go to this one. During my last slide, whatever I showed you, this one, this was in 1972. Afterwards, no human being has reached the surface of the moon. It is more than nearly 50 years. Okay, but now anyway, plans are there to go back to moon with the help of rockets again. Now we are living in a very, very, very crucial time, very exciting time, because all these years, from the time Yuri Gagarin went to reach space and started circling the Earth, only well-trained astronauts, many of them are test pilots in the first few years of space age. Nowadays, a lot of scientists were also going, NASA scientists, European Space Agency scientists, Russian scientists, like that, they were all going. But all of them were professional astronauts or cosmonauts, whatever we call. They were professional space travelers who were trained for a long time. But now we have reached a time, okay, in which anybody can go to space. Those people who have maintained, ordinary people who have maintained their health well, they can go to space as space tourists. Okay, if you pay 1.8 crore Indian rupees, you can take this plane. Okay, this is a plane, space plane. This is the one. This is a space plane built by Virgin Galactic, Richard Branson's company. Okay, you can sit in that. About 6 people can sit there inside, apart from pilots. Okay, and this is an aircraft which carries it to a height of let us say 50,000 feet. But this is the one, from 50,000 feet high, there is a rocket engine there, it goes to space. So if you have 1.8 crore rupees, means you can travel to space, you can reach space today. See, this is the exciting time. It was not easy all these years, for nearly 60 years. Okay, look at that. This is the Spaceship 2 spacecraft. Okay, so Virgin Galactic spacecraft, which was which carried Richard Branson and some more people into space. It went and zoom. It went up to the edge of space, entered space. It all depends on the way we look at space, and using this rocket engine. Okay, rocket engine. It is covered in this picture. Okay, so it went to space and it came back safely. And look at it. So all of you know what is Amazon. Okay, Amazon.com, everybody knows. Okay, so the boss of that, Jeff Bezos, is there. He has started a space company called, okay, it is called Blue Origin. That is the name of the company. Richard Branson's company is Virgin Galactic, and this is Blue Origin. So this is not a rocket aircraft, Blue Origin's New Shepard rocket, but it is a rocket. What does it do? It can take 7 people there on top there. It can take, and what it does is it can go up to space, touch the edge of space, make the people to reach space and to experience weightlessness for 3 minutes, and after getting launched within 11 minutes it can come back and land. Okay, this separates the passenger portion separates and the rocket separates, both of them, they will come and land. So this is around 1.4 crores to maybe 1.6 crores. That is the actually the price you have to pay as passenger to reach space and experience the sense of weightlessness. So even 60 years back for Yuri Gagarin it was rocket. Even for space tourists today it is rocket. And one more interesting thing, when Richard Branson went to space in the rocket plane, and Jeff Bezos also went to space in a rocket, that is Blue Origin, what I showed you. Many people started getting excited. Yeah, everybody can reach space now, provided they have a lot of money. It is not at all difficult. You need not be an astronaut, they were thinking. But there is a difference between just going up, reaching space, experiencing weightlessness, and coming back. But very recently, one American company called SpaceX launched four ordinary people to space. This time they did not, like Richard Branson and Jeff Bezos, they did not just reach space and come back within 1 hour or 10 minutes, something like that. For 3 days, they were circling the Earth in their Crew Dragon spacecraft, and all of them safely came back. None of them are professional astronauts. See, now things have been proven. This is far more significant because all the 4 people are ordinary people, and one of them is a cancer survivor, and she has got prosthetics, that is a rod is implanted in her thigh. Okay, and all others are regular people. Okay, the thing is that is ordinary people. Now ordinary people, sick people who have recovered, everybody is going to space. So space travel is becoming much more easier and much more affordable. Who is responsible for this? I mean, what is responsible for this? Rockets. So to reach space, you need to have rocket. And now already plans are there to go back to moon in 2024. Americans are already having an Artemis program. So in huge rockets, they are going to launch people. They will go and explore the surface of the moon and stay there, not coming back in 3 days and all those things. Months together or years together, they will stay there. And of course, more than humans are excited by Mars. Okay, even to go to Mars, you need to have a rocket. So again and again, I'm insisting on that. Now, what is a rocket? So I talked about very high ideals like going to Mars and all those things. Now, I have come back to something which is so trivial. It looks so, it's a toy rocket. It is called water rocket. Okay, this I have conducted when I was in ISRO. I have conducted all over India. I have conducted water rocket launches. Look at that. So why I'm showing this slide is, what is a rocket after all? A rocket is a means of making something to reach space. That is, a rocket is a means of propelling something, that is making it to move. Okay, so actually a jet of water is coming out, pressurized water is coming out of this water rocket from the back of the rocket, and in response to that, so as a reaction to that, the rocket is moving forward. This water rocket is moving forward. This rocket, I built it myself. Okay, look at that. This is the launcher. This I launched it in Mumbai long back. Okay, so a rocket is a principle of propulsion or even a rocket is a small device. It can be like a Deepavali rocket also. And a rocket is an engine also. Look at that. I'm long back, some 5-6 years back, this picture of mine was taken in an exhibition in Bengaluru. I'm holding one rocket engine in my hand. Okay, this is the hero, because this was the rocket engine that made possible our Mars orbiter spacecraft to go and circle Mars. Be proud of it. Thanks to this rocket engine, India became the first Asian country to reach Mars successfully in its very first attempt. And believe me, Mars orbiter spacecraft is circling Mars even today. It was built to be there in Mars orbit and circling it for 6 months. If it were to do successfully, we would have been happy. But instead of 6 months, even after 7 years, it has been successful thanks to this rocket engine, ultimately. And the thing is, a rocket is a huge vehicle also. First, I told you, a rocket is a means of propulsion, a device. A rocket is an engine. A rocket is a huge vehicle which is capable of making a satellite or a spacecraft or human beings to reach space. Okay, reaching space means rockets are the only means which we know today. And rockets are essential not only to reach space, even to travel in space to a required destination, towards the required target. You need rockets to change its course. Okay, that's the way. This is our Mars orbiter spacecraft, and this is the engine I was holding in my hand. Okay, this is an illustration. And now let us talk about rockets. When I'll just explain the principles of rockets, then I will tell you about the complexity of rockets. See, rockets can be, depending on the type of propellant burnt by the rocket, used by the rocket, rockets can be categorized. They can be divided into 3 groups: solid propellant rockets, liquid propellant rockets, cryogenic rocket engines. Okay, cryogenic rockets. Sir, what is this word you are using, propellant? Is it not fuel? Yes, to a certain extent, yes. See, if I want to travel from Bangalore to Guntur, I can come by my car, okay, which uses petrol as fuel. And I can come by a bus or a train, which many trains use diesel fuel, okay. And or even if I come by a Volvo bus, it uses diesel. And if I come by plane, it uses aviation kerosene, okay, or a petrol kind of thing it uses, okay. But that fuel has to combust, then only something will be made to rotate, in the case of either jet engines or petrol engine or diesel engine. But on the surface of the earth, and even at the height at which aeroplanes fly, okay, if you have fuel, and to ignite the fuel, you can take oxygen from the atmosphere. But that is not possible in the case of a rocket, because the rocket has to reach extremely high altitudes, and then it has to reach space where there is no air at all. So in a rocket, you have to, in addition to fuel, you have to carry an oxygen supplying compound called oxidizer. So fuel and oxidizer together are known as propellants. Okay, it is like, telling father and mother every time. Instead of telling like that, we can say parents. So like parents, here fuel and oxidizer together, they are known as propellants. So we don't say solid fuel rocket, we say solid propellant rocket. So a solid propellant rocket has propellant in the form of a solid. So there are different organic compounds are there, and oxidizers are there, okay, and what are known as fuel binders are there. They are used to they are used to propel the rocket. So the propellants can be in the form of solids, But there are some disadvantages in solid propellant rocket. Once you ignite solid propellants, you cannot stop. Till the end, they will be burning. And they are not very efficient. They are like old Fiat cars kind of thing. Okay. Compared to that, there is a liquid propellant rocket. So there, both fuel and oxidizer, that is propellants, are in the form of liquids. So these liquids, they are pumped into the combustion chamber here, combustion chamber of this rocket engine, using turbo pumps. Okay. But compared to a solid propellant rocket engine, a liquid propellant rocket engine is more efficient. It is like, my car gives 20 kilometers per liter, your car gives only 10 kilometers per liter, like that. Compared to solid propellant rockets, liquid propellant rockets are more efficient. And you can control them, start them and stop them at your will, whenever you feel like. It is not that easy, but anyway, for students to know, it is very much essential that liquid rocket engines can be started and stopped anytime we want. So normally in these kind of rocket engines, we use hydrazine as propellant and nitrogen tetroxide as the oxidizer, a kind of hydrazine. And third thing is we have a third kind of rocket known as cryogenic rocket engine. Okay, what is a cryogenic rocket engine? A rocket engine which uses cryogenic propellants. What is cryogenic propellants? Cryogenic means low temperature. Why low temperature is required for propellants? Because a cryogenic rocket engine uses liquid hydrogen as fuel, liquid oxygen as the oxidizer. You know that hydrogen is a gas at normal temperature and pressure. Oxygen is a gas. We are all supposed to be breathing oxygen. Okay. So, but how do you turn oxygen and hydrogen into liquids? So you have to create low temperature to make oxygen to turn into a liquid. Okay. To turn oxygen into a liquid from gaseous state, you have to create a temperature of minus 183 degrees centigrade. In the case of hydrogen, it is far worse. You have to create a temperature of minus 253 degrees centigrade to turn it into a liquid. Then you use turbo pumps and feed them to rocket engine. So it will be super efficient. Cryogenic rocket engine is super efficient. India has mastered all the three types of rocket technologies. Now, I told you solid propellant rockets are very simple, but they are not efficient. And once you start them, you cannot stop them. My dear friends, let me tell you one thing. Whatever I explained you in the case of solid rockets, it is only principle. But a rocket stage, whether it is solid or liquid, is a very, very complex thing. Okay, very complex thing, because this is the structure. You cannot just like that build a structure like a car and all those things. It has to be very light, it has to be very strong. So this is where 3D manufacture or additive manufacturing is coming. That is 3D technology. I'll come to that. So a rocket consists of many parts, thousands of parts. Okay, each has to be very, very accurate. For example, this is the nozzle of the rocket engine. Nozzle of the rocket engine, it is not easy to build. So building and attaching it to the other parts of the rocket, testing all these things take a lot of time, lot of effort, lot of skill, lot of money, and thousands of parts and components are needed. This is the part of the first stage of our PSLV rocket. Part of the first stage, not the part of an entire rocket. Part of the very first stage of PSLV. And this is taken in Sriharikota. Okay, this picture. Look at it. So complex. And this is a liquid rocket engine. Okay, this is called Vikas rocket engine, named after Vikram Ambalal Sarabhai. Short form is Vikas. Look at that. This is the rocket stage and this is the rocket engine. Engine itself is very, very complex. A liquid rocket engine, you have to have many valves, many pressure gauges, okay, pressure regulators, so many things. Okay, look at that, how big it is. So this is the liquid rocket engine which is more complex compared to solids. And in the case of a cryogenic rocket engine, this is the cryogenic rocket stage of our GSLV Mark III vehicle, which launched Chandrayaan-2 to orbit. Look at that. This is the kind of complexity which is there for cryogenic rocket engines is mind-boggling, really, I tell you. Mind-boggling, you cannot even imagine. So, it's not easy. All these days, it was not easy to build a rocket. I'll come to details a little bit later. Now, let me show you. Launching a rocket also is not easy. You see, the thing is, building a rocket. You see, for example, PSLV consists of 4 stages. And in addition to 4 stages, it has got many a times, it has got 6 rockets which are surrounding the first stage, and they give more punch at the time of liftoff, and they are known as strap-ons. Okay, it is not easy to build a rocket and to test it. But anyway, once you build and test it, it will be the only thing that will take the satellite, or in the case of other rockets, even human beings. This rocket has already launched not one satellite, it has made 104 satellites to reach space and start circling the Earth. Look at that,
10,
just
9, 8, 7, 6, 5, 4, 3, 2, 1, 0, plus 1, 2,
look at that.
3,
Lift off.
Lift off normal.
प्रक्षेपण सफल तैयार.
tracking.
Very fantastic, steady flight of the
P1 tracking.
lift off. It is
P2
moving up.
tracking.
I can see the way it is going, how steadily it is going. आप बड़ी आसानी
See,
से
if
देख
this
पा रहे
is
हैं
to
कि
happen,
प्रक्षेपण step on
see, I have to build a rocket which is a very, very complex
सीधे
thing.
आकाश की ओर अपने
Then
कदम
only it
पर
will work.
और हम बाकायदा
Otherwise, it
उसकी
may
आवाज
explode
अपने
also.
कानों तक सुन पा रहे हैं.
So, building a rocket is not easy. Why I'm telling this?
Acoustic levels of the vehicle going up.
There is a reason for this. I will tell you.
And the whole mission control center is reverberating with the sounds that have emanated from the liftoff. You can
Okay.
see steadily the launch vehicle.
Okay, this is the thing. Now, I told you this is a very, very momentous time. This is a very exciting time. What I showed you was PSLV launch. Okay, once we launch a PSLV, we cannot reuse it. Okay, that PSLV's work is over. Okay, it is as good as, students taking a bicycle, going to their school, reaching it and throwing their bicycle. Do we do it? If we do it, that's all of us will go pauper. Okay, we cannot maintain it all. But in the case of space, this was the thing. Why I'm telling that it is exciting time? Look at this this clipping. Now we have a company called SpaceX which launches a rocket. See, this is the Falcon 9 rocket which takes satellites into space. Okay, it makes them to reach space and to circle the Earth. But the launches become quite cheap. Okay, why? I'll show you. Just now you look at this, what Falcon 9 does. See, it is a revolutionary development which has occurred. See, the first stage of the rocket, it has separated, and look at that in the left side, it is coming and landing. So we are able to reuse the rocket. Okay, we are able to reuse the rocket. This is the first time, okay, we could able to reuse something which launched something into space. Okay, even American space shuttle was there. They used to say that it could be reused, but that is not fully correct. But this SpaceX Falcon 9 has made reusable rocket a reality. So reaching space has become much, much easier in the sense from the financial point of view. Okay, it has become cheap. In the American space shuttle, to launch a satellite 1 kg into space to go around the Earth, and to make it to go around the Earth, you would have spent more than $54,000. $54,000 multiplied by 75. That was the rate. Now this rocket can launch 1 kg satellite, a satellite weighing 1 kg into space at a cost of only $2,700. Where is 2,700? Where is 54,000? Okay. So it is 20 times the cost has come down. So this is a very exciting time, and to take us much further, we need new ways of building rockets, new ways of, okay, in a way I can say manufacturing rockets. So when rockets are built, all these days, rockets were built using conventional rocket building techniques. Conventional means that is there for a long time, normal. See, rockets are built from millions of complex components and thousands of parts. Actually, when people went to moon, Neil Armstrong, Edwin Aldrin, Michael Collins went to moon, that Saturn V rocket, in one of my lectures, I showed the liftoff of that. It was built with more than, let us say, 5 million components and 5,600 parts. Okay. And that is why it was very costly. In addition to that, see, in order to build those components individually and thousands of parts individually, lot of time, lot of money, lot of effort is needed. And once you build them, integrate, that is bring them together, integrate them, test them, something goes wrong, again you have to repeat. So all these things were costly. Similarly, the kind of manufacturing which was used for building rockets, even in India, what we use is by and large subtractive manufacturing. Forget about the name. What you do is you take a metal piece, either in the form of a cube or in the form of a rod, or in some crude shape in which you want. You take it, and from that you have to craft. That is, you have to build something related to rocket very, very accurately in terms of dimensions also. In that process, you have to cut some parts, okay, cut some metal, cut some plastic, or cut some other material. A lot of wastage will be there in that. But you have to very precisely manufacture these things, assemble them, and integrate them. That is, join them one to each other. And testing also, it takes a lot of time. I told you, if tests were not to go properly, it fails. Again, you have to repeat, redesign, rebuild, and retest again. And large manufacturing facilities were needed for building rockets. If you see the rocket factories, even if you see some of the facilities in Sriharikota, you feel like crying really with excitement. Okay, that is where there is a thing called SPRAB in Sriharikota, where our solid propellant rockets are manufactured. Fantastic facilities. Let us be proud as Indians. That is the kind of thing. Then large labor force, so many people, thousands of people are required to build rockets, all the components of the rockets in so many places. It takes a lot of time, costs are very high, and you have to manufacture or build rockets on the surface of the earth. Where else you go? How can you establish large manufacturing facilities in space which are required for building rockets like that on the moon or Mars? It was not easy because of the type of manufacturing. So I'll repeat once again, look at this rocket engine. Millions of components will be there, thousands of parts. See, look at that. It looks so complex. This is a rocket engine belonging to, which belonged to the space shuttle. So very, very complex. This is the turbo pump. Okay, this is the combustion chamber. Okay, so this is the way propellant feeding system. So difficult it is. And this is the Saturn V rocket. I told you 5 million parts were there, and each of these engines, okay, was so complex. And I took this picture at the Kennedy Space Center in the United States when I visited there. See, 5,600 parts and more than 5 million components, that is smaller ones, were there. Look at that. That is, after building rocket engines, joining it to the stage, building a rocket from using those rocket engines It is very time consuming and costly. Look at that. This is the second stage of PSLV, which is being attached to the other parts of the rocket. Look at that, my colleagues at that time. So they look like Lilliputs here, Lilliputs. What I want to show is it's so huge, and testing is very time consuming. Okay, long testing times, very complex, costly. If something goes wrong, again you have to retest it. Takes years together. But that is why there is a new way of manufacturing. What I told you earlier, this old way of manufacturing, conventional rocket building, is called subtractive manufacture. That is, subtract means you have something, a large block, from that you start cutting down and shaping the piece as you want. Lot of wastage is there. It is called subtractive manufacturing. But instead of that, you have today what is known as additive manufacturing. Additive manufacturing, that is, you add one by one, layer by layer you build using computers. Okay, that additive manufacturing is also known as 3D printing. They say not exactly the same, but people are using it for students level. It is like this. So this is a new way of manufacturing rockets. Okay, so what is the speciality of this additive manufacturing? This is exactly the opposite of subtractive manufacturing, which was conventional. There you take a big block, started cutting it. It is like taking a big wooden piece and making something out of it. It is like making an idol from wood. That is the way it is. Okay, so an antique piece, making it, lot of wastage will be there. Okay, or even that when from gold you make necklaces and all those things, wastage will be there. So that is subtractive manufacturing. But additive manufacturing is opposite of that. This is computer controlled, and 3D shapes can be created by putting layer by one layer upon the other one, like that. Using computers and special tools, you can create anything, including a rocket engine and the entire rocket launch vehicle. And it is possible to manufacture complex components using this technology. And this is a new manufacturing process. I told you, the things using lasers, using computers, you can deposit, you can take metal powder and start depositing one layer over the other, and you can build the entire rocket engine like that. Even a very small manufacturing facility is sufficient for you need not have very big industries and all those things. Small means not in your room, but anyway, comparatively smaller. Reduction in manufacturing time. So in very quickly you can manufacture. See, one company, startup company, is making more than 40 rockets in a year. Startup means just now it has started. And you have freedom to design the way in which you like. You can imagine a rocket engine the way you like and do it. Weight reduction is also possible. Okay, weight reduction, because the design is like that, weight reduction is possible. Costs are lower. You need not have many people. Okay, you need not have millions of components. You need not have thousands of parts. You can reduce it to a few dozen. That's all. So in reduction in the number of parts of a rocket is possible. Testing time can be reduced. See, I asked you a question. Manufacturing, using old way of manufacturing, we had to have industry on the earth. Now because small facilities are are sufficient to manufacture rocket engines using 3D printing, you can establish them even in Earth orbit. In International Space Station also they have established. And on Moon and Mars, you can establish industries. What are the advantages of 3D printing? You are enhancing, that is, you are increasing the efficiency of manufacturing. And because you are using digital computers, you can manipulate many things. You can easily manipulate things and manufacture rockets. You can, parts will become stronger, in fact. And As I told you, the correct word to use is additive manufacturing, but one type of additive manufacturing is 3D printing. That is, add layer by layer, adds material to create an object. See here, when an object is, I told you, traditional way of building things, lot of wastage because you are cutting, milling, machining, okay, carving. I told you from metal how you can build an idol, okay, wastage will be there. But here, fabrication, that is manufacturing or building, is simple, okay, and you use computer aided design software in this regard, or 3D scanning as the basic tool for building rocket engines using 3D printing. See, look at that. This is one picture showing small. You see, look at that. Within this much, he's building a rocket engine. I'll show you a clipping. Okay, this is one American company. Okay, and this is the one, and this is the same company. Okay, small manufacturing facilities, high efficiency. High efficiency is possible. Okay, this is this American company, same company, this one, and now look at that. And here you can see how layer by layer, how additive manufacturing works. That is how 3D printing works. Look at that. Can you see this? Of course, they are taken very fast. See, using a laser, they are building. Look at that. Look at that. Layer by layer, using laser and metal powder, they are building. Look at that. This is the way a rocket, solid propellant motor is being built. Look at that. Now we will appreciate how it can be done. See, quite quick. See, this is the way. See, instead of taking a metal piece, or the take a metal of approximate shape, okay, what we say forgings, that is at a higher level. That's why I'm not using such things. Okay, now what you do is, for school students is sufficient. Instead of taking a crudely shaped metallic sphere or a metallic shape from a particular material, metal, alloy, plastic, whatnot, and ultimately building a rocket engine, you can use, actually I can, you can, what you can do is, you can use additive manufacturing or 3D printing. And what are all the advantages it has got, already I explained. See, now using 3D printing, that is additive manufacturing, you can build more rocket engines in the same time, where you build not this many rocket engines. In 1 month, if you build one rocket, now you can build 2-3 rocket engines. Just as an example, I am telling. See, for example, there is an American company called Arbex. Okay, here they have built a rocket engine using 3D technology only. Look at this. Using 3D technology, they have built this rocket engine. Okay, and this is yet another, this one. See, using additive manufacturing, this is the thing they have built. And this is the entire launch vehicle, and you see the rocket engine there. Okay, what you saw here, you are seeing there. Now, because of the advantages of this 3D printing, lot of companies in America which build rocket engines using conventional technology, they are going to change over to the 3D printing technology. Not everything, because they have got their limitations, but new companies which are known as startups, they are there. They are just they are doing exciting thing. Okay, this is a launch vehicle called Terran 1. The company is Relativity Space. I must thank them, because see, all these pictures what I showed you from here, this is all Relativity Space. That is the name of the company, founded by two people. Look at them. They are standing there, and they are the ones who built this Relativity Space company. Once again, I will show you what is 3D printing or additive manufacturing. Look at that, the way in which it is being built. Of course, this is not the exact rate, but it is speeded up for taking picture. But anyway, very quickly and efficiently, without wastage and without many people, rocket engines can be developed using 3D printing technology or additive manufacturing technology. So this is the advantage. See, yeah, this is the way. So the examples and advantages of additive manufacturing. Now you see this relativity space is building an entire launch vehicle using 3D printing technology. And of course, I repeat once again, because small manufacturing facilities are sufficient for 3D printing or additive manufacturing, even an international space station, they want to manufacture some small things even. Okay, so they can manufacture it there itself. Okay, small things, of course, not very big ones, because instead of that, they had to carry a lot of spares, which was wasteful. It is not essential. So now, thanks to 3D technology and the flexibility and the advantages, even moon can be turned into a manufacturing base in the future. From 2024 onwards, human beings are going back to moon. And of course, Mars also can be turned as a manufacturing base, as a place where human beings can live. So all these things are possible because reaching space will become more easier, more cheaper, and less cumbersome. Okay, and it becomes quick thanks to the new way of manufacturing rocket engines. I repeat once again, to reach space, rocket engine is the only thing which we know. And to manufacture rocket engine quickly, easily, without complexity, and very quite cheaply, okay, quite at an affordable price, 3D printing technology is helping. Another name is additive manufacturing. Okay, of course, sir, you talked about only Indian, American companies. What about Indian companies? You can see Narendra Modi ji there inspecting one of the Indian startups called Agnikul Cosmos. They are building a rocket engine using 3D technology, and they also want to build the entire rocket, okay, entire rocket using 3D technology. Okay, so all said and done, India has got a lot of prospects in 3D technology, in building rockets. And today our share in global space economy, that is so much of money is being earned by so many in America and Russia and many other places. And we are not getting that much business thanks to these startups like Agnikul Cosmos and many other things, through aerospace and such things, and additive manufacturing or 3D printing technology. India's real power in using space for good business can be demonstrated. This is the best time all the students can see what young people are doing. When you grow up, you can also take up challenging tasks like this of new ways of manufacture, and you can reach space and expanding our knowledge horizon about the universe. So thank you very much. In this lecture today, what I have told you is, to reach space, rocket is the only thing, I repeat. And to manufacture rockets, once upon all these days, it was difficult. And nowadays, very recent years and recent months, thanks to 3D printing technology, we can expand the rocket business, and cost of reaching space will come down like anything. And it is good for the exploration and utilization of space, not only for the world, but for India. Thank you. Thank you very much. I'll stop at this stage. Thank you, Shantamurthy Garu. Once again, I thank the Children's Space Club of India for inviting me. Okay, I saw Jaikar, Mr. Jaikar. Good evening to you.
Thank you.
Thank you.
Thank you, sir, for your wonderful presentation.
Thank you very
So,
much. This is a subject which is not as easy as our other things, but I tried my level best to show pictures, and I tried my level best to bring them to their level. I have made an honest attempt. Let us see how they take it. Okay.
Really, it was so fascinating, so interesting for children. I hope will be profitable for children and more
Yeah,
useful
yeah.
students. So over to Mr. Kopala Jaikar to say a vote of thanks for
Yeah.
the from 27, 28, 29. Every day we are having 2 sessions. So
Yeah.
we held this program with a vote of thanks.
Yeah.
Over to Mr. Kopala Jaikar. Jaikar,
Thank
please.
you, sir.
Yeah. Thank you.
Thank you, sir. Thank you very much, sir. Thank you very much for this wonderful opportunity to greet Sri Guru Prasad Garu, the eminent scientist who work for different countries, space agencies like Japan and NASA, and even just he work for Germany. We are very, very grateful to have you, sir, and we are very happy to have you. And your lectures always just insist the children and motivate the children. And I have a confidence that your lecture is a lecture that makes the children and takes the children to your level. I just that it's that's the level of your lecture and level of your presentation, sir. Thank you very much.
Thank
And we are very grateful to the state government also. State government when and where we asked for a permission to just broadcast and orientation classes through live programs through YouTube. Government then and there immediately just sanctioned all permissions and intimated all the DEOs and the deputy educational officers, and they circulated and just they gave instructions to all the education departments to have these wonderful orientation programs. And we especially thank for the Andhra Pradesh state government, and especially Sri Chinavera Badrudu, I think he's a director of school education. And the second thing is, and Srinivas Children's Space Club of India, which is just working for more than 15 years for the space education, and it is just rendering its services to just to make all the children, all the even rural children to visit ISRO, NASA, ISRO, Russian space agencies like Yuri Gagarin space agencies, and wonderful activities carrying out by Children's Space Club of India. And other thing is Srinivas Garu, science student, and we have wonderful personalities just who are working for space education, because our leader and the founder chairman Santamurthy, just he always just believe that the space education just makes the sense of the human or human relations into the sky. Yes, it makes reach the sky. So that is the greatness of space education. By just studying or by just knowing regarding the space, just we can flourish in our values and human relations. That's the great motivation given by Santamurthy Garu. And we have eminent personalities from 27th to 29th, all the way. So we have so many people like Sri Ramamurthy Garu, a retired NRSC Hyderabad the scientist, and Anand Babu Garu, who just awarded as a citizen scientist from NASA. And so we have Varanasi Durga Prasad Garu, who is rendering his services as PGT teacher in Tummalapenta, APR school Tummalapenta, and R Varaprasad Garu, who worked for ISRO also, and some other and Dr. So who is I'm sorry, sir, Dr. Shashagir Rao Garu, a distinguished scientist from ISRO, and the great and eminent personality Sri Guru Prasad Garu, Dr. Guru Prasad Garu at the last session. We thank each and every mentor just who strived their best to educate, ignite the minds of the children regarding the space education and space modules. And I just wish all the children all the best for their competition, by just taking your advices and just whatever you gave. Just of course they may not get any prize today, or the competition is important, the participation is important. And here through these classes, I think worthy, the lakhs and lakhs worthy of information and intelligence and knowledge just spread out to the world. So for that, we especially thank each and everyone from Ramamurthy Garu to Guru Prasad Garu, whoever attended from 27th to 29th and making this wonderful sessions or orienters classes as a big success. And I especially and finally thank Sri G. Santamurthy Garu just for arranging and getting this wonderful opportunity and information for children of Andhra Pradesh, not only Andhra Pradesh. Here we have, sir, it is a wonderful issue that to know from Maharashtra, all over the India, Maharashtra,
Yes.
Tamil Nadu, Bangalore, Tibetan model schools, and almost all entire nation is just watching and getting knowledge through these in Children's Space Club of India and Science Student programs. And we thank you very much, sir. We thank you very much. Thank you one and all for just who are just behind these program to make this a grand success. Thank you very much. And sir, shall we conclude this meeting, sir?
Speaker, so submitting the project presentation ATL Space Challenge extended up to October 7th.
Okay, sir.
Please, October 7th.
So I request all the students to submit your ATL Space Challenge combinedly conducted by ISRO and Niti Aayog and Indian government. So you submit your ideas, your views and your projects by 7th October and just try to participate in challenges like that. You don't think that as always Guru Prasad sir always says that Abdul Kalam is not at all the toppest student of the class. He is also a common student and he is a very normal student, just wonderfully rendered his services as the 11th president of India. Likewise, and this Guru Prasad gar also, just I want to tell a small word regarding him. And he hailed from a very remote rural area, and just he rendered his services for United States of America, NASA and German Space Center, and he worked as an advisor for even Japanese space centers. So children, there is no border, there is no limit for your achievement. There is attitude is altitude. That's all. Just you keep it in your mind and you participate, whether you get a prize or not, but you present yourselves and be a wonderful participant. So I thank each and everyone, and I once again I remind you that please submit your projects by 7th October, and try to get attention of the entire world. Thank you very much, sir. Anything to say, or otherwise can I wind it up?
No, actually, as you said,
Sir.
Attitude is altitude. You said by having the right attitude, you can reach high altitude.
Yes, sir.
Right attitude leads to high altitude.
Yes, sir.
Oh,
Right.
That's the way it is.
I want to add you a small issue, sir. Right attitude, bright altitude.
Yeah, bright altitude. Yes, brightest altitude. Yeah. Okay. Thank you very much.
If we are in a right way, the boldness or the what can we call the brilliancy that gives us the bright way. That brilliancy in the right way gives us the bright life. Thank you very much, sir. Thank you very much.
Yes, sir. No doubt. Thank you very much. I enjoyed it. Hopefully, people who listened also have enjoyed. Thank you very much.
Thank you, sir. Thank you, sir. Santamurthy, sir, shall I wind the program up?
Yes, with the national anthem.
Okay, sir. Right. So thank you once again. Thank you very much. Thank you one and all for participating, and each and every student and all the students all over the world and all over the country, by having a wonderful opportunity to listen to Mr. Guru Prasad Garu and other eminent personalities from last 27th. I thank each and everyone just who participated and made this program a wonderful success. Thank you very much, and let us end our program or conclude our program with the national anthem. Just I urge each and everyone to stand in your positions. जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल वंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गादा जनगण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद. Thank you very much.
Okay. Thanks, Shantamurthy. Bye.
Thank you, everyone. Thank you, sir. Guru Prasad sir.
Thank you. Thank you very much. We'll meet again.
Thank you. Good day. Good night.
Good night, sir.
Good night. Good night. Good night, Shekhar ji. Thank you.